welcome back to another video, or no, sorry, YouTube short. In this one, I'm going to be talking about the couple of tips and tricks I wanted to show you guys when it came to differentiation. And yeah, I might do a few other things, I might not. I sometimes do it as it goes, you know. I don't completely have a script for this video, so yeah, I don't really do scripts for my videos, but yeah. So yeah, let's see how it goes. So for one thing, let me quickly actually just do a text box. Okay, so in differentiation, when you're trying to find the derivative of any function, one thing you may notice is that the constants in constants in that function disappear. Disappear, I think, yeah. And the reason why this happens is that, like, when we go back to like this part, which is function of x plus delta x minus f of x, this part right here, whatever constant that's contained, like whenever you're adding or subtracting a constant in that function, what happens is that that constant isn't affected by the x variable because it doesn't really depend on it. So when you subtract f of x, you're subtracting that constant away. So that constant just disappears. And yeah. So like if I were to do like function of let's say our function is function of x is equal to 3x plus 2. I think we did this example, but yeah, 3x plus 2. Yeah. We did this in our previous in our part 2 video for the series. So yeah, 3x plus 2. The derivative of this function, which is delta bracket f of x bracket. You can write it like this as well, divided by or over delta x. So this would equal function of x plus delta x, right? And that's just equal to 3 into x plus delta x, 3 into x plus delta x, and we just put the spaces. It just helps organize. And plus well, actually, we can ignore the actually no, never mind, not ignore, but okay, 3 into x plus delta x plus 2, right? That's the function when we add delta x to x, and then we would subtract from this. We subtract 3x plus 2, so minus 3x 3x plus or minus 2, because you're subtracting well, like if you did this, but you would have to put brackets because that's the entire, this is the function, this over here is the function, 3x plus 2 is the function. So when you subtract it, you kind of like distribute the subtraction to 3x, and just do that and distribute it to 2 plus 2, so it becomes minus 2. So then what happens is that if we distribute this 3 into x and plus 3 into delta x, so then this equals 3x plus 3 delta x into delta x, yeah, and then plus 2 and minus 2 cancel out, so it just becomes 0, and minus 3x. And yeah, this is our result. But then we have when we see that minus 3x and plus 3x, so we cancel these, this and this, so it just becomes 3 times delta x. And 3 times delta x, we forgot to divide by delta x, right? Because of this part. Yeah, but now we just bring that back. I should do an arrow. It's not equal, but here, yeah, an arrow. So yeah, 3 times delta x divided by delta x, and this is equal to 3. And yeah, the derivative slash slope, which can also be represented by m, is 3. So yeah. And one other thing you would probably notice is that when you have a linear function like our example we just did, 3x plus 2, the derivative of any linear function is always just the what do you call it, the coefficient of x, of the variable x, and the coefficient is just the number that comes in front of x. So if I just have x alone, that's also equivalent to 1 times x, 1 times x. So the derivative of the function, when a function of x is equal to x, that the derivative is 1, or the slope is 1. Um, so yeah. And here's another one. We'll be discussing the proof of this later in future videos, definitely. In fact, but if you guys know the proofs, and you guys could let me know down in the comments below. But the derivative of any power of x, like let's say function of x, right, is equal to y, which is equal to x to the power any number, and we could just say this number, we could represent this number as constant with n. Okay, so x to the power, here, let me quickly space, okay. So the derivative of any power of x, the derivative, delta y over delta x of any where y is x to the power n. So let's just quickly replace that with x to the power n. Bold. Okay, yeah. So so delta x to the power n divided by delta x. The derivative of x to the power n is always equal to n into x to the power n minus 1 space. Yeah. And you can just remove it, but yeah, nx to the n minus 1, yeah. And that's the kind of formula, and it's a little bit complicated. I think, yeah, in part 3 of the series, I also did introduce a different one, the antiderivative. I think if you watch the video, yeah, of part 3, the antiderivative I wrote was of any power of x, I wrote was x to the power n plus 1, plus 1, plus 1, divided by n plus 1. And you can kind of see like there are similarities, and when like you try to find the derivative and the antiderivative, there are slight similarities, like, yeah, but the proof of these I need to like also kind of like try and understand. So if you guys know, you can let me know in the comments below. But yeah, I think that's basically it. If I'm missing any kind of like tips and tricks, you guys should totally let me know, you know? So yeah, thank you. Thanks, yeah, for watching, and see you guys next time. Bye.